Hi, everyone. I'm Asma Qandaharyun from MIT and presenting on behalf of Natasha Jakes, whom unfortunately couldn't be here today due to delays in her visa. This work is called Way of Policy Deep Reinforcement Learning of Implicit Human Preferences and Dialog. So I'm going to argue that an AI agent that is aware of social cues is going to be smarter. This is an actual conversation that happened between a user and Alexa. Alexa, what's the right way to Walmart? And then Alexa responds, the right way to spell Walmart is W-A-L. Well, as you can tell, this is not what she wanted. So I bet what she does next is show some sort of frustration, either in her tone of voice or her choice of words or something. Wouldn't it be great if Alexa could actually pick up on that cue and adjust its behavior? However, we don't like to provide explicit feedback. It's just too hard for people to do that. It doesn't scale. On the other hand, social cues are just natural. They happen regardless, ubiquitously, and we just do them for free anyways. I don't know about you, but I've at least raised my eyebrows at my laptop a couple of times today. So in particular, in this project, we focus on the text domain. And we try to have a generative dialogue model that is aware of this implicit rewards. So using a state-of-the-art sentiment detection model, we can tell when the user says, that didn't make sense. That actually means that the conversation is not going well, so we can use this as a negative incentive. On the other hand, when the conversation is going well, we can use this as a positive reward. So toward this end, we made this platform. You can check it out at neural.chat, where we deploy a bunch of different neural dialogue models and have actual humans talk to them and rate them after an interactive setting. As you might have noticed in this interface, we have included these buttons that allow people to upvote or downvote that single utterance. And we ask people, encourage them, beg them to please rate these utterances. On the other hand, we still hypothesize that these explicit responses are not going to scale because people don't like to do them that often. We also formulated a range of different implicit rewards based on our reading of what constitutes a good human-human conversation from psychology literature. For example, things related to sentiment and sentiment transition, keeping the users engaged by having them talk to our bots longer and use more number of utterances, as well as semantic-related metrics. Additionally, we added an extra reward related to asking questions because that represents being an active listener. On the other hand, keep this in mind because this is exploitable. The bot can only ask questions without bothering to have a good conversation. We'll get back to this later. So our setting is an RL setting where the environment is human, and rewards actually come from interactions with humans. However, we can't just have a chatbot and deploy it online, because it may end up saying inappropriate things. So what we want to have instead is this broken interaction loop where we inspect our policy before putting it back online again. This is called the batch RL setting, which is very challenging because we are trying to learn off policy from a static batch of data without being able to explore. But why batch RL is hard? This is one toy environment to illustrate that. Let's say the problem is that this little robot wants to get to this red flag as quickly as possible. However, it's only given this part of the data set, the part of the state space that is shown in yellow here. So if its original policy is just initiated in a way that it thinks it's a good idea to go up or left, it has no way of refining that estimate and getting back on track. You may say that why not just do behavioral cloning or imitation learning? The problem with that is that it gives us suboptimal results. So what we want to do instead is have a KL constraint to make sure that our RL policy stays close to this part of the data set that we have, at the same time trying to optimize for these rewards that we care for. So in the dialogue setting, it will be generating realistic language while trying to optimize for those implicit, sentiment-related, and semantic-related metrics that I talked about. So to formalize this, what we want to do is not only maximize the expected future reward, but we also want to minimize the KL divergence between our RL policy and the pre-trained prior, which in our case is a good language model or dialogue model. However, we do a couple of other tricks to make this work in the batch RL setting, such as having soft target updates, as well as having Monte Carlo dropout to get an estimation of uncertainty over the target Q values and getting the minimum over that, so that we deal with the problem of over-optimization that default Q learning has. For more information, please feel free to check out our paper. How does this work in practice? So these are the results from the vanilla batch Q setting. As you see, it doesn't really create realistic language. For example, it says, "Where did you say to me?" And also, it exploits those rewards that we just mentioned. For example, in every single utterance, it tries to ask a question, and it spams by using the most number of tokens available during each utterance. On the other hand, the KL control models, they generate more realistic language, and also they have shifted their distribution toward a more cheerful, polite, and supportive language. For example, in response to "What's up?" it says, "I'm not sure, but I'm glad to see you." So next, let's look at how humans actually evaluated these models. So after chatting interactively with our models, we see that the baseline Q models actually don't do as well in terms of metrics of quality, fluency, diversity, relatedness, and empathy. On the other hand, the KL control models are significantly outperforming those baselines after running a single one-way ANOVA test in terms of the total sum of these different ratings. We also add additional experiments in the OpenAI Gym environment of CartPoll. So I encourage you to go check out our paper to see these additional results if you're interested. We also look at how these reward functions compare. So overall, we see that sentiment is doing the best across all these different rewards, both in terms of human quality metrics and also these implicit human rewards that we mentioned, which kind of reflects our hypothesis that affect is important for having a good quality conversation. Also, we see that those manual votes don't do as well. They score lower, which again validates our hypothesis that asking for explicit feedback is just too much work and is not as scalable. So in conclusion, we can say that our work was one of the first to propose KL control from a pre-trained prior in a batch RL setting. And also, we showed that implicit rewards actually work better than explicit button presses in learning human preferences. Please feel free to stop by our poster tonight. And also, Natasha will be here for the conversational AI workshop as well and presenting this work there as well, too. Thank you.